Good morning, everybody. Welcome to your first day of online school. Now, those of you who've been with us before and have been in our 6 to 12 environment before, what do we always start the year with? Yes, a great lesson. Today, I'm going to tell you the first great story. I want you to use your imagination and I want you to think about things in this. If you've heard the story before, I want you to see if I tell it the same way as I told it last year, or if I tell it the same way that Cindy tells it, or Rebecca tells it. Let's think about the differences and let's see what's important in this story. At first, there was absolutely nothing. There was only the deep, dark, immense magnitude of space. It was indescribably cold and indescribably dark. Now, when you and I think of dark, we think of nighttime. But our nighttime would be like a blazing sunny day compared to the dark of space. When we think of cold, we think of ice. We think of something we take out of our fridge. But do you know that our ice would be positively hot compared to the freezing coldness of space at that time? In this measureless void of cold and darkness was a tiny little speck. Watch here how I sharpen my pencil and make this tiny little dot. That little speck was even tinier than this mark I made. In this tiny speck was everything. All that ever was, all that ever will be. The potential of everything was hiding in that tiny little speck. One day, no one knows why, no one really knows how, bang, something happened. All that ever was and all that ever will be was tired of hiding. It was tired of being in that tiny little speck. It came rushing out in a blinding flash of light. It appeared like a vast fiery cloud, which included all the stars which are in the sky. The whole universe was in that cloud, and among that was our tiny, tiny little world. But there were no stars as yet, as there was nothing except light and heat. So intense was the heat that all the substances we know, like iron and gold and rocks and water, only existed as gases. This raging cloud of nothingness, too huge to even imagine, was floating through space, but our space is so enormous that that huge cloud was like a drop of water in the ocean. But that cloud contained everything. That cloud contained all our stars. It contained our sun, which is actually just a star. It contained all the planets, and it contained our Earth. As this cloud moved through space, tiny little drops fell from it. Like if you swing the water if you filled a bucket with water and you had to swing it around like that, might be something you would like to try. Some water drops out, tiny little bits of it, but a lot of it stays together. Well, it was the same thing with this cloud. All the stars that we can see in the sky are those tiny drops that fell out from that big moving cloud. Some of them are so far away that it takes the light they let out millions of years to reach us. Do you know how fast light travels? Do you think it's 100 kilometers an hour? Maybe 1,000 kilometers an hour. What about 2,000 kilometers an hour? No. Light travels 300,000 kilometers, not per hour, per second. Can you believe that? 300,000 kilometers per second. In 1 second, light from the sun can travel around our Earth 8 times. In 1 second, just like that. The circumference of our Earth is 40,000 kilometers. If we had a magic car that could drive at 160 kilometers per hour, and you know that's even faster than we can go on the highway, if we could drive that car at 160 kilometers per hour all day and all night, not even stopping one time, no breaks at all, it would take us 10 days to travel 40,000 kilometers. Can you imagine that? But light does it in 1 second. How amazing! So let's all click our fingers and think about how much light has traveled when we do that. Let's go. Every second, light is traveling 300,000 kilometers. That's really something intense. So you can imagine how far away some of these stars are in the sky that we see at night if their light takes millions of years to reach us. There are so many stars in the sky that scientists have calculated that if each star was a tiny little grain of sand and they put all of that sand together, that sand would cover the whole of South Africa and some of our neighboring countries up to 200 meters high. That is enormous. Think about it. If you're sitting inside watching this and you look up to your ceiling is about 3 meters away from the floor. So imagine 200 meters. Wow. One of the grains of sand among the billions of grains of sand was our sun. One wouldn't think so. The sun doesn't look so big, but that is because it is so far away. The light from it takes 8 minutes to reach us. And remember our magic car? If we had to be in our magic car again, driving 160 kilometers per hour, it would take us 106 years to reach the sun. But the sun can send its light to us in 8 minutes. Isn't that amazing? I want you to look at this chart. The sun is 1 million times bigger than the Earth. The sun is so big that one of its flames could contain 22 Earths. All the little particles were given rules to follow. When the universe was created, every speck, even those we might think too tiny to matter, was given a set of rules to follow. To the little particles, which were like smoke, which could only be distinguished as light and heat moving at a fantastic speed, their rule was as you become cold, you should become closer and become smaller. And so as they cooled and they moved more and more slowly, clinging together closer and closer to each other, occupying less and less space, the particles assumed different states, which man has called solid, liquid, and gas. I'm going to show you a little experiment. Everything we know is either a gas, a liquid, or a solid. And which of these three states it is at the moment depends on how hot or cold it is. Nature made other laws. To all the tiny little particles, nature whispered in their ear and said, you will like some other particles and you will dislike others. You can see how some particles were attracted to others and other particles weren't. When it came to liquids, nature said, you shall hold closely together, but not very closely. You will have no shape of your own. Instead, you will roll over each other. You will flow and spread, filling every hollow, every crevice in your path. You will push downwards and sideways, but never upwards. That is why we can put our hand into water, but we cannot put our hand inside a rock. And to the gases, nature said, your particles shall not cling together at all. Gases may move freely about in all directions. But as the particles are all so different, they did not become solid or liquid or gas all at the same time. At a certain temperature, some remained solid, while others became liquid, and still others became gaseous. Let's look at this experiment. This one's becoming gas. This one is a liquid. And look at this. And so, while obeying these laws and the particles being attracted to each other or repelling from each other, our world started to form. Look at this chart. It looks like a dance of the elements. The particles that are on the outermost edge become cold and shrink, huddling together, and they hurry to the earth. But as soon as they approached the hotter part of the earth, they became hot and went up again, just like little angels. They carried a bucket of hot burning coal into space and returned with some ice. How marvelous it is, and how simple. If you become hot, you expand. You become lighter and soar upwards like a bubble of air in the water. But if you become cold, you shrink and fall as a grain of sand sinks to the bottom of a pond. Because of this law, the earth gradually changed from a ball of fire to the earth we know today. This was the law that the tiny radiant particles obeyed as they danced their dance. Particles too minute to be seen or even imagined, yet numerous enough to have produced our world. For hundreds, thousands, millions of years, this dance went on. Finally, the particles settled down, like tired dancers, and one after another, they became first liquid and then solid. And as they became solid or liquid, some of them joined others, to which they were attracted, forming new substances. The heavier ones went nearer to the heart of the earth, and the lighter ones floated above them. What can you see happening? Can you see the heavier particles have sunk to the bottom and the lighter particles have floated above? A thin scum was formed, like the skin which forms on top of milk when it's boiled left to cool. It seemed as though the earth had taken some shape. But the elements inside the skin were still very hot, and they started to feel trapped. They wanted to get out. They wanted to follow their rule. But what could they do? What was their law? Their law was, if you are hot, you expand. There was no place to expand, so they burst out and they broke the skin. It was like a terrible, terrible fight. Bursting through the skin, the water that formed on the surface turned immediately into vapor and went up as the hot stuff came pouring out from inside the earth. There were also ashes. A veil of cloud was drawn to cover the earth so that nobody could see what was going on. It was as though the sun was ashamed of them. Eventually, the fighting ceased. As everybody cooled down, more and more gases became liquids. More and more liquids became solids. The earth itself shrank and became wrinkled like an old apple that's been left in the cupboard. The wrinkles are the mountains and the hollows are the ocean. For as soon as the rocks had cooled down, water was again able to return to the earth. And it rained, and it rained, and it rained. And the water, being liquid, filled out every hollow and every crevice in its path. Thus the oceans were formed. Around them was air, the air we breathe. The horrible ash cloud had disappeared. The veil was drawn, and the sun could once again smile upon its beautiful daughter, the earth.